Next important topic is DAX. DAX stands for Data Analytics Expression. And here we will take a look at what is DAX is all about, why DAX, and what is X Velocity engine is all about. And previously it was called as a Vertipack engine. And then we will move ahead and take a look at what are the operators and data types that are available in DAX. And then we will jump into understanding what are the different aggregation functions that are available. The rest of them, we will see if we have time, we will cover it. Okay. So what exactly DAX is nothing but, what is DAX? It's a combination of functions, operator, constants that we used in a formula. So remember that, DAX is not only used in Power BI, it is used in Excel, Power Pit, and even Power Pivot and SSAS tabular edition, even Azure Analyst Service also it is available. DAX can only be used to filter or query a physical table. Remember this, using DAX, you cannot do data transformation and all, okay? You can create a derived columns using DAX, okay, but you cannot do extensive data transformation, everything ETL and all, you cannot do it. So using DAX, you can filter and you can query a physical table. So now the question is, why should I use DAX? So the using DAX, you can, the DAX function, these are the built-in function. It helps you to get most out of your data to solve your business problems efficiently. Okay. And other advantage of using DAX is once you create the DAX formula, you can reuse it in different places. Okay. And you can use a measure in another measure also. Okay. And those kind of things you can do it. And to create complex or customized formulas, we cannot rely only on sum and average. That will not be sufficient. We may have to use some additional functions or more functions in order to solve some, or the address some complex business scenarios, use cases. So why to use? So look here, the on the left side we can see the total sales. On the right side of the total sales we can see the equal sign, and then followed by the equal sign you can see sum, and inside that you have the sales column. This is total sales is a measure here. Okay, it's a measure. So where are the DAX for? Next question is, where are the DAX formulas used in, right? So you have something called calculated tables, calculator columns, measure. This is very important, guys. This is the one they will ask you in the interview. So calculated tables. So, most frequently the DAX formulas are used in measures and calculated columns. Sometimes we use calculated tables also, okay? And what is the difference between DAX and M language? This is another interview question. So Power BI supports M language and DAX. When did we discuss about M language? As part of Power Query Editor, okay? So both the DAX and M language are completely independent. It is not dependent. You cannot use DAX function in your M language, and the opposite is also same, okay? And M is a query formal language. It is used in Power Query Editor, whereas the DAX is an analytical data calculation language. So next one is DAX engine. This is very important. What is a DAX engine? The measures, or whatever the DAX formula that you use it, right? That one is processed by the two engines. One is called formula engine, other one is called storage engine. Okay. These two engines work together to compress and encode raw data and assess your DAX queries. So what is the role of formula engine, storage engine exactly? Okay, to take a deep dive. So this block diagram can help you to understand it. For example, you have used a measure called total revenue in Chicago. On the right side of the equal sign, this is where you use the DAX function called calculate. The sale is sum of sales, and filter function you're using. So basically you want to check, you want to compute how much total sales we made in Chicago. For that, you have written a DAX query. Once you write a DAX query, what will happen is, right? So it will be it will send a request to your formula engine. Okay, formula engine, what it does is it accepts your DAX request, and then it processes your DAX request and generates the query plan. This query plan will be sent to your storage engine, and depends on the type of the storage mode. For example, you have used the import connectivity mode. So let's say you have used the import mode, right, for your customer table or sales fact table or something like that. So in the case of the import table, what will happen is it will see the formula engine generates the query plan, And since it's an import mode, what happens? The query plan will be sent to your storage engine. And here, the X velocity engine, what it does is, since you have used the import mode, X velocity engine will get started. It will get kick started. And what it does is, it performs three tasks. One is it will convert your tabular data into columnar data, and then what happens is it will compress the columnar data, and then it will load the data in memory. Okay. So first task carried out by X velocity is it will convert your tabular. What is tabular data? Rows and columns into columnar data. Okay. And second step is once it converts your tabular data into columnar data, it compresses your data, and then it load the compressed data in memory. Anything in memory, the performance will be pretty faster. It's something like, if I ask you your mom's contact number, you can tell instantly because it is stored in your in memory. If I ask your maid's contact number, you need to check your mobile phone. So to get her number, you need to check your mobile phone. It takes time to tell your maid's contact number because it is not in memory. Since your mom's number, contact number is there in your memory, you can tell instantly. So that is how, if you load the data in memory, the performance will be pretty faster. But loading the data, for example, I have 10 GB data, but in my laptop, I just have, 8 GB data. But if you load the 10 GB data, since you just have the 8 GB RAM, right, it will be too slow. It will not get loaded, or, it will be, it will take longer time, right? Your system will hang. So what Power BI does is, especially the X velocity engine, what it does is it compresses your data. So the 10 GB, almost, right, it compressed to 1 GB. Okay. So loading 1 GB in your 8 GB RAM laptop will not, does not require too much of memory, right? So it compresses the data. When you load the compresses data in your RAM, in your memory, system memory, it saves a lot of space, RAM, right? RAM space, right? So in this case, just 1 GB space only is required in the RAM. So it compresses the data, and then, all right, since this data is available in memory, the performance is pretty faster. Okay. But here, this is what the process, the intro, they'll ask you, what are the DAX engines? Can you tell me what is formula engine, what is storage engine? Formula engine, what it does is, this is the query I have written it, right? Forget about all the things. So here, the whole idea of this one is calculate what is the total sales we made in Chicago. This is a DAX query. So when you submit a DAX query, what will happen is, first, it behind the scene, right? It goes to your formula engine. The formula engine, it accept this request, and then it process this. Are there any syntax error or anything? It parses it. If nothing is there, it generate the query plan. It's just something like your GPS. Google GPS, right? So with the GPS, you can find out which one is the short out route to reach your office, or let's say you want to go to a mall from your home. So which one is the shortest route, right? It gives you that one. So it's kind of a map. Okay, the query plan, it tells you, hey, to process this query, how do you need to access the data, right? And how fast you can access it. What is the access path that you need to use it, right? That query plan will get generated. That query plan will be sent to your storage engine. Storage engine, what it does, since it's an import mode, the X velocity engine will wake up, and then it carries out these three stars. And what happens is, the data, once the compressed data get loaded in memory, which is nothing but the cache data, that will be sent back to the data cache will be sent back to your formula engine. And the formula engine will send this one to your visual, okay, your chart or visual, okay. And this is what is happening behind this. And in the case of direct query mode, the same DAX query, it will be accepted by the query plan, and then it parses it, and if there are no issues, right, it generates the query plan. This query plan will be sent directly to your SQL server or Oracle server, right? And then the query will get executed here, and the output of the query will be sent back to your formula engine. This one will be sent directly to your visual. That's all, guys. This is how the DAX engine works. Next one is the vertipack compression and encoding. Okay. There is a question from Preeti. Okay, yes. What is columnar database? Why it has to convert the row to column? Look here. So this is your row store and this is your column store. See, conventionally or traditionally, when you work with any RDBMS like Oracle or SQL Server, the data gets stored in table. Let's say you have, like this, right? This is a table. Okay. The date, let's say in the table you have date column, store column, product column, customer column, price is there. Okay. You want to find out the price for a specific product. Okay. You want to know the product for the specific price. You want to know the price for a specific product. In that case, the data can be selected only from product and price is more than sufficient. But what happens is behind the scene. Okay, let's say in your query, you want to select only the product and price. Okay, first, it goes and checks the first column. Hey, is this a product? No, it skips it. And then it goes to the next column. Is this a product? No, it skips it. And then it goes here. Yeah, yes, this is a product. And when it comes to price, it goes and checks, is the price? No, skip it. No, skip it, skip it. Okay, this, yes. It has to go and check, for each and every column, whether, the column, whether the first column is this column or not. Otherwise, it has to skip it. So especially, let's say in a table, you have 85 columns are there or 95 columns are there, and you have, 100 million records are there. So in that case, skipping will take longer time. So for that reason, what they did, each and every column, they stored it separately. So that if you want to select any specific column like product and price, it goes directly to this, column and, these two columns. Hence, the performance will be faster. For that reason, nowadays, the columnar databases, the NoSQL databases are gaining popularity. What are the NoSQL databases are there? The Cassandra, you have something called Cassandra. And if you know big data, right? So if you have any big data guys, don't know what is Cassandra, is a NoSQL database. And Mark Logic is another NoSQL database. And then HBase is another SQL, NoSQL database. These are all falls under NoSQL databases. So the NoSQL databases are more popular nowadays. So beyond this, now we have something called vector database. If you know data science, right? Vector database. Vector databases are pretty faster. And apart from this, we have graph database. Likewise, different types, came into picture. Okay, but at this point, you just understand what is, why it has to convert the tabular data into columnar data. Okay, because of the performance reasons. Is it clear, Preeti? Okay. Next one is, yeah, it compresses the data and load in the memory, right? So what is Vertipack? In the previous version, instead of X velocity, they named it as, previously it was called as Vertipack. Okay, and then they renamed it to X velocity for in the recent releases or in the recent version of the X velocity in the Power BI. Okay, hence you just remember X velocity is an engine, right? The DAX engine, and in the previously it was called as a Vertipack, the older name. Okay. So, okay, now we have seen, right, the data gets compressed and then it loads. What algorithms or techniques it uses to compresses the data. Okay, that is called encoding. Okay, Vertipack stores a compressed copy of the database in. That's what we have seen. So, what are the techniques it uses to compress the data? That is called the compressing. The technique is called encoding. And we have three types of encoding: value encoding, dictionary encoding, run length encoding. If you have integer data type, then value encoding, this mechanism used to compress the data. If you have text data, dictionary encoding is used. If it is repeating values, then RLE, run length encoding technique is used. And here, if you see what exactly the value encoding is all about. For example, you want to understand what is value encoding. This is used in the case of integer values, right? Value encoding when it is used. For example, in my column, I have these values. Okay, I told you value encoding is used on integer values. So these are the integer. What is the integer? These are whole numbers, right? So what is the maximum value here? What is the maximum value here? 216, isn't it? 216 is the maximum value, highest value. So to store these 3 digits, right, it requires 8 bits storage space. Okay, 8 bits is a very small one, fine. But when you use value encoding, what it does is it finds out the maximum value. Sorry, it finds out the minimum value of all these data sets. It finds out the data points. It finds out the minimum value. It subtract the minimum value from each and every value. For example, 194 minus 194 is 0. And 197 minus 194 is 3. That's how, right, the minimum value will get subtracted from each and every value. Now, in the three digits got reduced to 2 digits and 1 digits, right? And what is the maximum value here? Just 22. To store this value, right, it requires just 5 bits. So we are saving 3 bits storage space. You might be asking this question. This is a very trivial, reduction in, the space, right? So why we are carrying about 3 bits reduction and all? In this case, we have just, seeing that just 9 values data points. But when you deal with the huge volume of data, right? So let's say you have millions and millions of records. So in that case, obviously, right, the 5 bits into 100 million, how much? It's a huge number. You save that much of space. That is how it compresses the data. Okay. So it's a value encoding used for integer values. Next one is the hash encoding. This is for text data type. So for example, you have a column called color, okay, and you have different colors are there. So what happens is it builds a dictionary, something like that. So what happens here is it takes the unique value or the distinct value. So red, white, black, blue, these are the distinct value, and it assigns the integer values starting from 0. Okay, 0 is red and 1 is white and 2 is black and 3 is blue. What happens is it replaces the red by 0 and the white by 1, and wherever black is there, it is replacing the black by 2. Wherever the blue is there, replace that by 3. Got it? So this is another encoding technique for the text data type. Okay. So in this case, what happened? This column value got reduced to, this much size, only smaller, right? Only 1, 0, 0, 1, 2, 3, that's all. But whereas here red, black, white, right? So it requires a lot of storage, but here it requires less storage. But so what is 0? It goes and check here. 0 is red. So wherever 0 is there, that means red. Wherever 1 is there, that's white. So right, the dictionary and this one, right, with the help of the dictionary, it replaces this value like this. Hence, it reduces the space. Okay, next one is the run length encoding technique. For the repeating values, the run length, the technique is used. For example, I have a column called quarter, and Q1 is repeating almost 300 times, and Q2 repeats 290 times. And Q1, this value starts from the first position up to 310th, right? So 1 to 310 values we have Q1, and 311th to 290 we have Q2, okay, because 290 times are there, right? So starting from 311, so it reduces this one, and next one what happens? It's kind of the combination of dictionary as well as this technique, okay. So in this case, the dictionary comes into picture encoding. So we have seen, right? So here the Q1, Q2, Q3, Q4 is there. Okay, the unique values it takes here, the distinct one, Q1, Q2, Q3, 4, and it assigns the integer value 0 starting from 0. Okay, 0, 1, 2, 3. Wherever Q1 is there, it replaces it by 0. Wherever Q2 is there, replaced by 1. And next one is the data rows. Okay, for here 0, it goes and checks here also. 0 appears 310 times. The 1 has to appear 290 times, and 2 has to appear 225 times. This is how it compresses the data. So end of the day, we discussed about 3 encoding techniques. One is the value encoding, the next one is the hash encoding, the other one is run length encoding. So the hash encoding use it for integer values, the hash encoding used for text values, and run length encoding is used for repeating values. So these are the data types, right? The common data types that we use it in any programming language. The whole number is nothing but integer. it requires 64-bit, integer value, or you can, 8 byte, you can, use it. The integer value stored, you can, it uses 8 byte to store the integer values. You can store anywhere between this range, -9 to this big value to this big value. And similarly, the decimal number also 64-bit 8-byte real number. You can store the negative values, in this range, and positive, you can store it this way. This is the, range of values you can store it. The currency is also a fixed decimal number, and here it is also 64-bit 8-byte real number. You can stay, store the values anywhere between this one, and date and time, 64-bit 8-byte real number here also. So under the cover, right, you can store the values anywhere between March 1, 1900 to 999. Beyond this, you cannot store the value. Before this, you cannot store the value. And these are the text data type, blank, these are the different data types, right? And what are the operators, arithmetic, comparison, like all the programming, this is the thing. These are the operators are available. Arithmetic plus 3 plus 7 minus, what is minus? Star is multiplication. This is division. This is your exponentiation. And the comparison operator equal to first name. If you want to compare, the eon is there in this my data set, the first name column. So equal sign, and the strictly equal to double equal sign. Greater than, less than, greater than 100. For example, you want to, check the age is greater than 100 or sales is greater than 100, right? So A sales is less than 100. So these are inequality operators, less than, greater than, and logical operators, the ampersand. For example, you want to compare two conditions together, right? If you want to check only if the two conditions are true, then do some actions. For example, if the city is Chennai and the age of the people is less than 33, then they are eligible for something like salary hike or promotion. Okay. Only when the two conditions are true, then right. So in that case, right, you can use and, right, and operator. So true and true is equal to true. This is a truth table, okay? And true and false is false. False and true is false. Okay, you remember that. In the case of and operator, in the or operator, if true or true is true, false or true is also true. If any one of the conditions are true, then it will become true. If both of them are false, then it will be false. The mix of true and false is true or false is true. False or true is also true. But both of them are false means false only. Okay. But here both, but at least one condition should be true so that it will be true. Otherwise, it will be false. Both the conditions are false. For example, cities, I want to check city equal to Chennai. And in your case, you are living in Delhi, Preeti, okay. So in that case, the condition fails. And you are, let's assume that, you are, let's say your age is, here, let's say I'm using age is greater than 33. You are not, greater than 33. Here also fails, here also fails, and it's false. Okay. This is the truth table and in operator. So using in operator, you can compare more than one value in your column. For example, in my channel name column, select only the records that are related to store and online and catalog. Okay, so in this way you either store or online or catalog, you select it. Okay, so sales, store, online, catalog related records will be selected from this data set using in operator in this case. So instead of using in, you can use or, okay, where channel name is equal to store, or channel name equal to online, or channel name equal to catalog. So in that case, it will select all the values, it will return it, right? So instead of writing multiple ORs, you can use in. Next one is, these are the logical functions that are available in DAX, right? This one, we will discuss it in the next weekend. This weekend, not many of them join. Since it is an important topic, I urge you all to join. Anyhow, I will send a strong note, tomorrow. It is mandatory that all of you can join to the next week's session, okay? So henceforth, right, till I complete the DAX, it is very important, okay? Meanwhile, you can fast track, watch the SQL videos, SQL Server, all